over 1 and 2, right? So yeah, so it's going to be plus or minus 1 and plus or minus 1/2. So when you look at, this is probably not the best example to do. All right, when you look at this, okay. What do you notice? What do you notice about this graph? What now? Right?
Touches the x-axis and crosses.
It touches and crosses. So we have a bounce, don't we? What does a bounce mean?
No, it doesn't cross.
Right, I know it doesn't. What does it mean when you have a bounce? It's an even multiplicity, right? Oh, yeah. Okay. So our even multiplicity, it looks like between which of these is it? The 1/2. And if you want to double check, you can go to your table, which I have set up to 1/2, and see that, yep, 1/2 is a 0. Now, if you're looking at your table, you can't tell that's a multiplicity of 2. You've got to know about the bounce, right? So we're going to use 1/2 for our synthetic division. Half of 2 is 1. Half of -8 is -4. Half of 2 again is 1. Here's my 0. What do I have to do with these guys? Divide them by 2 because I've got that fraction. Okay, so we have x, well, we're going to do synthetic division again with another 1/2. It's a double root. One half of 1 is 1/2. Oh no, it's a fraction. What's 1/2 of -7 over 2? -7/4, right? We're just multiplying there. We've done something wrong. Come on, guys, it's Monday. It's not Monday anymore either. Huh? Okay, let's not divide here. Let's see if that helps our situation. Erase, erase, erase. It's okay. Still giving us trouble. You know what? Let's not worry about it. Let's go here. Maybe we don't have to do double synthetic division because this is already a quadratic. That's our problem. We already have a quadratic. We're going to factor out the 2, which is what we should have done in the first place. And then we're going to have to do the quadratic formula. Square roots of 12. How do you do that? 4 and 3. So it's going to be 4 plus or minus 2 square roots of 3 over 2. So that's what it equals. I like that question. Do you guys like that question?
No.
Something's wrong, isn't there? We should be passing through it again.
Yeah. Oh, block.
I'm losing my mind. We're going to start recording it now.
Yes. Oh, the back. Oh.
So, what we thought was a double root is not a double root. You had to look closer. All right, we're good. All right. Do we need to see another? Do you understand what you're doing? Okay. So, today, we're going to be the rules of signs, Descartes' rules of signs. So this is another way to narrow down back in the day when they did not use the calculator for everything. Okay? The number of real positive zeros, is either equal to the variations of sign or less that by a number of an even integer. So just write that down, and we'll kind of go over an example and you'll see what we're talking about. The number of negative reals, you're going to check the signs as well, but of f of negative x. So it's the same rule, but one you're looking at f of x, which is the original function, and the second one you're going to plug in a negative x and then look at the new function. And it's the number of variations or that number subtracted by 2 or subtracted by 4 or subtracted by 6 or whatever it might be. Okay? And again, this is just a, hey, this always works kind of thing. So, if you're looking at f of x here, how many times does a sign change? 3 times? So remember, this first guy's positive. So it changes 1, 2, 3 times. So there's 3 or 1, subtract 2, positive zeros. Okay? It's just that easy. Then you're going to plug in negative x. And apply the exponent. So that's going to become a negative x to the 5th. That negative stays. That becomes a positive 3x cubed. That negative disappears. So he stays as a minus 5x squared. Minus 9x minus 7. So then you look again. How many sign changes do you have? You have 1 here, 1 there. So 2. So there's 2 or 0 negative real zeros. So it's not a hard rule. You're just looking for sign changes. Okay, easy breezy. So then, if I did not have a calculator, I could use that other clue to help me narrow down how many zeros I have. All right, so what I would like you to do now is try the second one. See if you can do that one. All right, last thing we're going to talk about is upper and lower bound tests. So if you have a polynomial and we're using synthetic division and you look at your coefficient line, if every number on the line is non-negative, all positives are 0, then it's an upper bound, whatever you divide it by. Means no other zeros beyond it could be happening higher than that one, okay, greater than that one. If k is negative, and you do synthetic division with it, and you have the signs are alternating, positive, negative, positive, negative. Zero could be either one. So if you have a zero there, it could be alternating. Then k is a lower bound. So if k is positive and you put it in and you see all positives or zeros in your quotient line, then that's an upper bound. If k is negative, you put it in and you see alternating signs, then it's going to be a lower bound. Okay. So again, this is helpful when you're plugging in numbers. If you always start at the smallest positive and plug them in, just doing synthetic division instead of plugging in, you can tell where you can stop. Okay. When you get a zero and they are all positives or alternating. So let's try one. Carly?
Is there any reason that it's written as not
Because it can be zero also.
Okay.
Okay, so positive or zero.
Okay.
All right, so that's why they put that there. Yes, ma'am.
So if it was 0 for both of them, then what would it be?
They're saying if you see a zero on the line, you can count that as a positive or negative number, whichever works for you.
Okay.
If it's in the first one, you want to count it if they're all positives except the zero, it's all positive. Okay. All right, so let's try one. Find the upper and lower bound. So you have to figure out what the possible zeros are. So what are our possible zeros? Plus or minus 1, plus or minus 3 over 1 and 3. So plus or minus 1, plus or minus 3, plus or minus 1/3. That's it, right? 3 over 3 is already listed. So I'm going to start with the smallest. Let's start with 1. Easier. Let's start with 1. We're looking for an upper bound. So if I do synthetic division with 1, and really if you don't have your calculator and you don't want to plug it in, let's try it. Well, that's not a zero. So he's not going to be considered a bound. Go to the next one. Let's try 2. You're just doing synthetic division repeatedly. And that one's not going to work either, right? Why are you guys doing that?
That's just what we wanted.
This is why I never record first period, because I am like not even awake. Right. I should drink what Brett's drinking.
Oh, it gets energized, trust me.
I know. Do you want to know that? Okay. Oh, that's why, because I was looking at another example in the book. Okay. What do we have here? Something that's not a zero, right? So what's our last positive we can use? 1/3. Okay, 1/3 of 3 is 0. Oh, look, I have a 0. And what do you notice about all the numbers? They're all positive. So 1/3 is the highest 0 you can have. Because we already tried 1 and 3 and they didn't work anyway. But that's why we should have started with the smallest. I said start with the smallest and I still started with 1. Okay, start with the smallest negative. What would the smallest negative be? I'm sorry, the number closest to 0 in the negatives. Okay, negative 1/3. So we are looking for, if it's a 0, this one's not going to work. Now go to the next one. -1. That's not a 0. Go to the last one. What's the next number? In the negatives, -3. Doesn't work. The only 0 we have is, okay, 1/3. And the other two are going to have to be irrational, right? Okay. Guys, that's it. We've been tortured enough.